Okay, so sorry I had to put this video into parts because I accidentally put the stop button instead of pause. But it's okay. I mean, I hope you guys get to see this part anyways. Okay, so let's go ahead and continue with part two, okay, which is number nine. What volume? Now we're looking at dilutions. By the way, this is a dilution problem. This is dilutions, okay? And mainly it's just to make it less concentrated. You add more water, okay? So, at least that's one of the solvents, water. Uh, Basically, if you want it less stronger, then you would use dilution formula. Okay, so let's go ahead and get started. So, what volume of 6.0 molarity? Okay, what volume? Okay, and then this is usually there. You could just keep them in order. Like this is what volume is what you're looking for, so that would be your V1, and then this is your molarity. That would be your M1. So you could start on this side. It's fine. Okay, so it's needed to make 5.0 liters. So remember, if it's liters, then it has to be one of the V's. But since we already used V1 as the one that you're trying to solve, then this one will be your V2. Okay, and this one, the 3.0 molarity of HCl, that will be your M2. Okay, so we already used all of these, so now that you know which ones are, we're ready for the setup. Now, we're trying to solve your unknown is the one that you're trying to solve. Okay, so that one needs to be by itself. Okay, it has to be by itself. So it would be, let me see here. So it would be M1 V1 equals M2 V2. Now I want V1 by itself, so I need to move M1. I need to move this one to this other side. So if you guys remember how I showed you last time, is you need to look, the only way to move it to the other side of the equal sign is to look at the math behind it. Look, this is multiplying, right? M times V, right? So, so since that's multiply, you always use the opposite of that math, okay? So if it's multiply, you divide. If it's division, which is not in this occasion, then you multiply. If you add, then you subtract. If you subtract, then you add. So in here, you divide. So it will be M1 because that's the one we want to move. We want V1 to be by itself on the other side of the equal sign. Okay, so now we're going to do the same thing to the other side. Cancel this, and that's it. Okay, that will be my equation. That is the M2 V2 divided by M1. Okay, and on this occasion, since they're multiplying, whatever you're moving, you just divide it, really. Okay, in all of the problems. So anyways, let's get started. Okay, so V1, okay, so M2 would be your 5.0 liters. I'm sorry. Well, it really doesn't matter, really, if you think about it. Because you're going to be multiplying this one with this one. Okay, so it would be, we'll just put the V2 first, and then the M2 times the M2 3.0 molarity of HCl. Okay, so divide that. Okay, because anyways, again, this the B2 and M2, you're multiplying them here. So it doesn't matter. You could switch them around, give you the same answer, which is 15, right? Okay, and then the bottom would be the M1, which is 6.0 molarity of HCl. So this is 15. 5 times 3 is 15 divided by 6. So 15 divided by 6 would be 2.5. Okay, and then of course we're solving for V1, so that will be liters. Okay, let's look at the next one. Okay, so 3 liters, so that will be my V1. The 6.0 molarity, so that will be my M1, right? and it's diluted to a molarity of 8.3. That will be my M2. What is the final volume? That will be my V2. Okay, so again, M1, V1 equals M2, V2. And what are we solving for? This is your unknown. So we want V2 to be by itself on this side of the equal sign. So we need to move M2. So this is multiplying. So you just divide M2. You do the same thing to the other side. Cancel this. And now V2. And I'm going to rewrite it just so it could look prettier. V2, it's by itself. Yay. Okay, and then M1, V1 divided by M2. Okay, we're ready to plug it in. M1 is 6.0 molarity. V1 is 3 liters times, because right, it's multiplying times 3 liters, divided by M2, which is 3.3 molarity. Okay, so 6 times 3, that's 18, divided by 3.3. So that will be 18 divided by 3.3 equals, and I'm going to go ahead and just use 5.45. And since this is less than 5, I'll keep it as 45. So it's 5.45. And of course, we are looking for volume, so it is liters. Okay, that's how much it's gonna be. Okay. Okay, so now let's look at solubility rules. Keep in mind that that elements that make compounds soluble is sodium and potassium. There's no exceptions. And then, but however, so these are always soluble. Okay. However, uh, you know, there's some exceptions. There's the chlorine, bromine, and iodine, and the exceptions will be with silver, with lead, or mercury. Okay, that will be your exceptions when it cannot dissolve. Okay, so elements that make compounds insoluble is hydroxide. Okay, there's an exception though. There's with sodium, potassium, barium, and strontium. And then for sulfur, phosphate, and carbonate, there's some exceptions as well. Okay, there's sodium, potassium, and nitrate. Okay, so soluble, it dissolves in water, insoluble forms a precipitate. Okay, so which of the following compounds forms a precipitate that is insoluble? Okay, so on this one, I forgot to put in your option, but your options will be sodium chloride, potassium bromide, and barium hydroxide. Okay, or is it lead chloride? Okay, so for sodium chloride, we should probably forms a precipitate that is insoluble. Okay, so elements that make compounds insoluble. Okay, well, basically, like sodium chloride, right, would make it insoluble, mainly because of the sodium. The sodium here, there's like, well, actually, there's the exceptions. There's the sodium and there's a chloride. Okay, you see that? So that means the sodium chloride is soluble. Okay, so this one's soluble. It's not insoluble. Okay, so you're trying to find the one that is insoluble. So this one's potassium bromide. So potassium bromide are soluble. Okay, let me see. And then boron hydroxide. Boron hydroxide. And is it? Oh wait, it's barium. I'm sorry, it's barium hydroxide. So barium hydroxide, you see there's exceptions. So these are all soluble. Okay, these are all soluble. And then there's lead chloride. So lead chloride, basically, that make compounds. Uh, that will be the only one because of the exceptions here. You see, it's like a soluble, except if chlorine has lead. You see that? So this is the only one that is insoluble. Okay, so that would be the answer for that one. Okay, so we're gonna go ahead and look at the graph for this next one. And in the graph above, which solution dissolves the most at 60 degrees? So we're gonna be looking at, remember that solubility is where the amount it dissolves, and this is in grams, okay, the amount. Okay, and then of course the 60 degrees is on temperature, so it's right here, 60 degrees. And which solution dissolves the most? And it would be, so if you look at 60 degrees, we go up here, and basically this is the least, and then next, and then next, and then next, and basically the only one up here will be this line. Okay, so that will be your lead. Okay, it will be lead nitrate. Okay, and then let's look at the next one. In the graph below, which letter represents the saturated, unsaturated, and supersaturated? So saturated is on the line. Unsaturated is under the line. And then supersaturated is over the line. Okay, so this is the line right here. Okay, so saturated is on the line, so it's B. Unsaturated is under the line, which is C. And then super saturated is over the line, which is obviously A. Okay, number 14, solutions that conduct a current are called, now this is electric current, so these are electrolytes, and are made of ionic. So ionic is metal, it's metal plus non-metal elements. Okay, oil and water, you guys remember this is immiscible. They do not dissolve. And then soda is miscible. It does dissolve in water. The carbon dioxide does, and sugar are dissolved. And then number 17, the solid particles that dissociate into ions and allow the passage of an electric current are electrolytes. Okay, and that's it, you guys. Good luck on your test. I wish you the best.